Hello all. Welcome to the webinar today. We Numerical Analytic Instruments hosting this webinar on the topic of statistics test. We have two speakers today with us, Mr. Jalaj and Mrs. Mary Kim. And Jalaj, we've already given several introduction about Jalaj, but still I'll say a few words about Jalaj. Jalaj is an IB and IGCSE math educator. He's from Indonesia, and he's an examiner for Mathematics HL paper 1 and IEA paper. And then, over to Jalaj.
Wow, sure, great. So thanks, Reti, and hello, everyone. Welcome to this yet another exciting learning and collaborative session organized by Numerical Analytics. My name is Jalaj, and with me is my versatile colleague, Mary, and she's originally, little about Mary. Mary is currently teaching IB Diploma, higher level mathematics and IGCSE additional mathematics at like one of the top schools in Indonesia. And she is a maths leader, IB examiner for maths HL paper, and also she's an IEA moderator. She studied her mathematics and education in Korea. She's from South Korea, by the way, originally. And she did her PhD program at Louisiana State University in America. And from Louisiana State, she did her PhD in biostatistics at Louisiana State University Health Science Center. She taught an introduction course in biostatistics and facilitated a statistical lab when she was working at Louisiana State University in New Orleans, and this is her 10th year living in Indonesia. She is a passionate mother, passionate educator, passionate cyclist, passionate hiker. So anything that she does with full passion. And for her, after family and mathematics is her fitness, and she's always enthusiastic and collaborative, and we are fortunate to have her here today. Thank you so much for joining, Marie.
Hi, Jalaj. You are flattering me so much.
I'm
like
sharing
I'm very
what I know,
passionate
actually.
in everything.
Probably there are like more things which will come to know about you eventually, but like really we are fortunate you're with us, and like your main area of studies being statistics. I think in today's webinar, everyone will be benefited, including all the panelists.
Okay.
So
thank you so much for welcoming. And over the summer, right? One of my most waiting time is Saturday afternoon, meeting IB educators through this webinar. So I'm so glad to be part of it. Okay. Thank you so much.
Okay. So Marie, before we start, like I have some questions. Like
yes.
Our today's session is when in doubt, test it out.
Mm-hmm.
So when we talk about testing in statistics or say testing in mathematics, mm-hmm. what exactly do we mean by testing? Is it some sort of testing, formative testing, summative testing, or we do some testing in, what exactly is testing in maths, and when do we do and why do we do? Would you like to shed some light on this?
I would say that in our daily life, we always come up with some kind of hypothesis. What I mean, a hypothesis is like, you could propose, hey, I am taller than you. Is it really true? How can we test, right? Or, oh, today's spaghetti seems to be salty, or those things, right? And what we are thinking of, sometimes we are doubting whether our thoughts and someone's claim is true or not, right? And then we collect the data, right? Some samples, and then once to test out our claim or someone else's claim, that's the statistic test.
Okay.
What do you think?
Mm-hmm. Okay, so you mean when there is a claim from the population,
Mhm.
And if you wish to check the validity of that claim,
Yeah.
like
You want to validate.
in TOK, we say knowledge claim. So when somebody claims to know something, or when somebody says something.
Oh,
So,
you're talking about TOK.
actually, as an educator, we all are TOK teachers also.
Yes.
So you mean when something is claimed about the population, or we have a population claim and we are not very happy with that claim, then we test that claim with the help of mathematics, with the help of statistics. And that is basically hypothesis testing. Is that you wanted to say?
Yes, that's a hypothesis
Great.
test.
So, okay, so then I have two more questions for you.
Yes.
I'll be asking you lots of questions today. When we say population claim, and you're not happy with the claim and you would like to test your claim.
Mm-hmm.
When we talk about the population claim, then on what basis do we say that this claim is probably not correct? Is based upon your sample.
Based on sample, yes.
Okay, so for example, like you have a mouse and company says if you use our batteries in this mouse, these batteries will last for, let's say, 20 hours. Non-stop, you can use it for 20 hours. You bought a pair of batteries and you realize that after 7 or 8 hours, batteries are drained out. And it happened several times, again and again it happened. So we start suspecting that there is something wrong with company's claim, right?
Yes.
So when the population claim and the sample observation, there is a difference in these two, we start suspecting and we need to do some testing. And if maybe there's something wrong with my mouse, or maybe there's something wrong with the batteries, right? So we have to test.
It might be the manufacturer, right? They claim to promote their product, they claim wrong, right?
Right.
You want to prove, right? You want to say that, hey, you are wrong, right?
True. So in that case, we do hypothesis testing, right? Now, my question is, when we talk about hypothesis testing, what are different kinds of hypothesis testing we do?
Are you talking about in IB?
In IB, yes. Okay, so are there different kinds of hypothesis testing when it comes to IB diploma or A-level?
So what are the different type of hypothesis testing? We might have Z-test or T-test, or we can have T-test, which is the paired matched pair sample test, and there could be two sample T-tests, or they could be chi-square test, which is the categorical data, and the chi-square test is going to be, there are two of them, and one is goodness of fit test, the other one is independence test. Right?
I see.
Now you are showing the Z-test, right? So let me ask you, when do we use Z-test?
Okay,
and what's the difference from Z-test and T-test?
If I see here in the Z-test, like it gives us a very clear clear indication to use the Z-test. So Z-test we are using when we test for population mean. Like when companies claim on average something has been happening this way, and you're not happy with that on average statement, generalized statement, that is the population mean, we can do Z-test. But if we see it, see here, it is very clear. If I see here in this first branch of the tree, Z-test, when data input method is stats, and another one is data input method is data. So when we have stats or we have data, in both cases, if I see here, I need to know what is mu naught, what is sigma, what is x bar, and what is n in case of stat, and otherwise list. But there are two things we need to have. One is mu naught and second is sigma. Now this mu naught is our population mean, or say claim, the claim for the population. And the second thing is sigma. Sigma is the population standard deviation. So whether we use stat, or we use data, we need to know what is population standard deviation. So if we don't have population standard deviation, we cannot use z-test. So for sure, for to use z-test, we need to have population standard deviation.
So what if we don't know the population standard deviation?
Okay, if we don't know population standard deviation, we can find the standard deviation with the help of the sample. Now, when we find it with the help of sample, it is not population standard deviation. This is sample standard deviation. Also, if we use calculator to find the standard deviation, there are two values given by the calculator. The bigger value, we should always take the bigger value, right? And that is basically unbiased estimation of population standard deviation. If you remember the last year in option 8 in statistics, there used to be something called estimators.
Yeah, estimator.
So we need to use population unbiased estimation of population standard deviation. And in that case, what we use is t-test. We don't use z-test anymore. If we see in like A level or in AP, that is advanced placement, there is something called, if the sample size is 30 or more, the central limit theorem suggests that if sample size is big enough, they say, but practically if it is 30 or more, you may use or you may approximate the situation with the help of Z distribution.
Normal distribution,
if, the sigma is given or not given. But in IB syllabus, it is explicitly stated, if sigma is not given, use t-test. If sigma is given, use z-test. So next is t-test. So would you like to discuss a bit about t-test with our great participants?
It's more the sample one, right? So as you mentioned, if t-test, right, only thing difference from z-test, t-test, it calculates sample standard deviation and use sample standard deviation as standard deviation. As you can see, the previous slide, can you go back to previous slide?
Sure.
And you see the sigma is showing. Now, next one, t-test, it changed as SX. That's sample standard deviation, right? So that will be used for that, right? And otherwise, everything is same. And you could also see N, which is number of sample is considered. Depends on the number of sample, the critical values are all changed. That gives a degree of freedom.
Right.
Oh, I just mentioned the degree of freedom. What is the degree of freedom in t-test? It's going to be, if you are testing only mean, so you are testing only one parameter, so it will be n-1 will be the degree of freedom.
Yes, always one less than the sample size.
Yeah.
Maria, I have one more doubt here. I saw in the previous slide where we were using z-test, and now when we are using t-test, there's something called alternate hypothesis, which is it is a drop-down menu. It would be mu is equal to mu naught. Mu is more than mu naught, mu is less than mu naught. So we are just talking about alternate hypothesis. It means the null hypothesis is fixed for everything. Is it?
Null hypothesis is always same. Null hypothesis is always, there is no difference. They are same, equal to each other. So mu1 equals to mu2, or mu equals to mu null, right? Mu equals to mu null means the mean of sample mean is equals to whatever the claim that you want to test, right?
Okay, so it's always like that. And when I was browsing through this calculator, I saw two more things. So let me quickly move into this. Two sample t-test. What exactly is two sample t-test here?
Two sample t-test, when you have two different population, there could be, right, these two can be similar. So what might be good? Like you have one field and the other field, you're gonna scatter the seed, and then you wanna compare how the crops are producing, how the harvests are like. Right. So when you have two similar, somewhat similar, but you want to compare their mean value, that's going to be two sample t-test.
And I also saw there is something called like paired t-test. So can we use t-test as a paired and unpaired both?
T-test could be paired or unpaired, but it is different. If it is paired, then the observation, individual observation must be same. So what it means, each observation must be same. So when you mentioned about the Olympic, right? So when we want to compare a group of player, right? And we have training, right? So we want to test whether the training is effective, right? So we want to test the result prior the test, prior the training and after post training. So and the players, let's say if we select 10 players, right? Those 10 players must be the same player, not the different player. So prior and after.
So do you mean that when it comes to the paired t-test, then in that case, we have to test the same sample 2 times? Is it?
Same sample 2 times, right?
Same sample 2 times.
Yes.
And when it is unpaired, then we have 2 independent samples.
Yeah, 2 independent samples. Yes, very good.
So you gave an example like before Olympic, somebody claims that if you undergo my training, your performance will improve. So 30 athletes join. So before the training and after the training, their performance was tested. Yes. So this is, since that is same sample tested twice, so we use paired t-test, right?
Yeah, and you know what is interesting about this paired t-test? We only need to concern about the difference. So what we could do is we're gonna subtract from the later post result, subtract the prior result, and then only consider that differences, right? D1, D2, D3, and all the way up to D.
So it is like a t-test then.
Right. So it will be similar to one sample t-test, and yet what we want to see is whether there is difference or not, right? If it is improvement, it is the alternative hypothesis will be D is greater than 0. Null hypothesis is D equals 0. So which means there is no difference.
But one more thing, like I saw there was an option, like if you look at on my screen in 2 sample t-test, the last option is pooled yes, pooled no.
Oh, yes. Thing? Yeah. Okay, to make the matter simple, right? Pooled and unpooled means, pooled means when you have 2 independent sets, right? And you can consider, right? You're testing the mean, but you can consider the variance if the variance is same or if the variance is different. And if you consider the variance is same, that's the pooled. If they consider the variance is different, then you consider the unpooled.
Okay, but in IB it says that you have to keep pooled yes, because both your samples will be taken in such a way that their variances are same, right?
Yeah. So
in IB exam, we have to keep it
yes. Variance is same.
Oh, that's wonderful.
Yeah.
And then quickly, I think we are taking too much of time in this discussion. So let's quickly look at the chi-square test. So chi-square test is basically, chi-square is the distribution like binomial distribution, normal distribution, t-distribution. Chi-squared is also a distribution. It is a continuous distribution. Since it is a squared, it is a positive distribution. And we use this distribution for 2 types of tests. And we also have this proportion test, which we are not going to discuss today, but it is there in your IB syllabus. So in chi-square, goodness of fit, and then we have chi-square 2-way test of independence. In goodness of fit, we exactly, please correct me if I'm wrong, Marie. So in goodness of fit test, whenever you are given data, then that data, if that data is following any specific pattern, now that pattern could be in terms of distribution, could be any pattern. So goodness of fit tests whether that data is following some pattern. And 2-way test checks the independence of 2 data to make it short. Am I right?
Yeah, correct. Yeah, correct.
Lovely. So
Yeah.
Mary, are we going to discuss all these things today with our participants here?
Yeah, sure, pretty much. We
So why don't we start with questions, some questions and some discussion here. So what I'll do is I'll stop sharing my screen.
Yeah.
And you please start sharing your screen and your expertise.
Okay,
Is it okay with you
sure.
to start first?
Okay. Can you see my screen?
Okay, yes, I can see a screen. And let me share something with our participants here. All these questions, we have actually selected some resources for you all. So I'll just share the link of those resources. But you can continue. I'll share those resources with participants now.
Sure. Right. Okay. Right. The first one is very typical IB question that we already know, right? This is kind of warm-up questions, right? So now, let me see. I want to get rid of this. How can I get rid of this? Maybe I could make it a little smaller.
Okay, I just shared a link with everyone. Please see if you can open.
Oh, by the way, someone was asking about pooled variance and unpooled variance.
Yeah, we discussed it actually.
We discussed it, so we can just move on, right?
Yeah, we can move on. Pooled, assume same variance. You answered this. Okay, can you all open this resource folder?
Okay, let me just make it smaller.
Yes, wonderful. Okay, so these questions are already, Marie, we have already shared these questions with all the participants.
Okay, all right. Okay, can you see my TI Inspire calculator and the questions?
Yes, we can see it.
Okay, good. Right. So the first question is very typical IB question. It could be either HL or SL, right? And let's see. Let's take a look at it. Digest the question first, right? See. It is that the time t minute taken to complete a jigsaw puzzle can be modeled by normal distribution with mean mu and standard deviation 8.6. It is found that 30% of time taken to complete jigsaw puzzle are longer than 36.8 minutes. And then by stating the solving appropriate equation show correct to 2 decimal place, the mu is 32.29. So how can we find out this first? So what distribution shall we use for this?
Anyone from participants, quickly, which distribution?
Yeah. So please go ahead. Don't be shy. What
because see, what we have not been given the mu, but we have standard deviation already.
Yeah,
here.
we have standard deviation and it is at normal, right?
And the moment we have standard deviation, we can use z-test.
Yes.
Or z distribution, in this case, z distribution.
Mm-hmm. Did anyone answer that? I cannot see the chat over here.
I don't see any answer here.
Uh-huh.
So I'm the winner.
Okay. Hold on. Let me see. I don't know how I can see the chat here. Oh, I see. Now I see. Good. All right. So
don't worry, I'll update you if there is anything there.
Okay. All right. So see, the first one we can think about. My best thing is always I draw the bell curve, right? So I'm gonna draw the bell curve, right? And then it is at 30% here. The 30%, right? 0.3 is taking 36.8, right? But we don't know mu, right? We don't know mu, right? So since we don't know mu, we cannot directly use norm, inverse norm, right? So, and then we could use G, right? Which is x minus mu over sigma, right? And x in this case is 36.8, right? Mu, we don't know. And then sigma is going to be 8.6, 8.6, right? And then sigma is 8.6. And because it's 30% over here, what do we need to use? What about the other side?
That should be 70%, right?
Yeah, the other side is going to be 70%, right? So I'm
Mhm.
gonna make it this side, right? Is going to be 70%, right? So this is 0.7, right? So
Yep.
when we use inverse z, right, we are going to use phi inverse 0.7, right?
Mhm.
And then when we use p 0.7, right, I'm showing my calculator over here. You can see the inverse norm 0.7 is going to be 0.524, right? So
Right.
we have 0.524, and then we can easily find out mu by cross multiplying, and then find mu is 32.29, right? Okay, the second part is knowing that mu is 32.29. So we can find out 86 percentile. How can we find out 86 percentile? We can just use normal distribution, right? So what I'm going to do, I'm going to go to stat probability distribution and the normal CDF, right? Normal CDF going up to, oh, no, this is the 86 percentile. So we know the probability. So we need to find the value x, right? So inverse norm distribution, inverse norm area is 0.86. And mu, I say mu as 30, and then 8.6, right? Ta-da! The answer is showing immediately that 46.
41.6.
Yeah, 40.
2-3 significant, yes.
Yeah.
That's great.
And then find the probability that randomly chosen person will take more than 30 minutes to complete the jigsaw puzzle. So this time we are looking for probability, right? Probability x is greater than 30, right? And then we could use, I prefer to use from left-hand side all the time. So 1 minus probability x is less than equals to 30, right? And then that will be 1 minus probability. So I will go over here, 1 minus probability distribution, normal CDF, right? And the boundary is 30, right? Up to 30, and mu. This is the advantage if you use the value saved in Word, right? And if you define it and keep on using it, that will be very useful, that you don't need to type all the time, right?
Yeah.
Okay, then when you do it,
this I have found it very, very useful when the students, they start defining the random variable.
right. So
when they have idea about random variable, then I think half the question is already solved, because they have a very good framework in their mind what random variable is, what kind of values will it take. So I always insist in my class, your first line should be, let x be the random variable representing blah blah blah.
Yeah,
it's always helpful.
Right. Okay. Oh, now next.
Sorry, we have I think we have a question here.
Right.
One moment, let me check the task. How did you get 0.524 using calculator? Okay, so I think Anuj is asking about question number 1, part B.
Oh, okay. So this is inverse normal. So as you can see, right? the
Sorry, no,
sep-
he's asking 0.524. 524 is, where is it?
Here, over here, the inverse norm. I didn't explain thoroughly, right? Because look at this, we transform into Z.
1A, yeah.
Yeah, so 1A, right? We transform into Z because we don't know mu value, right? So we don't know mu, so transform into Z. So it's like you are mapping, right? You are mapping to Z distribution with mean value is 0, right? Mean is 0 and standard deviation is 1, right? So you are mapping to this, right? And you want to find out Z value, which is mapping to this 36.8, right? So 36.8 minus Z, right? Standardizing, right? Minus mu over 8.6, right? And that is same as Z value that is mapping to 70%, right? So here there must be value Z over here, right? Which is equivalent to 70%, right? So in that case, we go, right? Menu, right? Menu, statistic, right? And then distribution, inverse norm, right? And then area is 0.7, right? And then do you see the value 0.524? Yes, good. Yeah.
And
yeah, using
also,
I see. Yes.
and we
So
can
now
also
let's-
use, later we can also use the numerical solve to
Yeah.
solve this equation.
Mhm.
On the left hand side, we can put this 36.8 minus mu divided by 8.6 is equal to inverse norm of 0.7, comma, your variable will be mu or x. Enter, you'll get your answer.
Yes. Yeah, I didn't go into that detail. Right?
Yeah. Yeah, can you show it once, Mary, to that?
Yeah, sure.
Yeah.
That will be
Go to
So what we have, right, 36.8 minus mu over 8.6 equals 0.524, right? And then if you cross multiply, we have 36.
No, we can do, can you do this way? Go to your calculator.
Oh, sure. So we can go with the calculator, right?
Menu.
So
Go to menu and solve. Algebra.
You go to and solve, right? Good.
Algebra and
You go to and solve.
Okay,
So
now you can write 36.8 minus x upon 8.6.
Right? And minus, let's put m, right? Okay.
Yep.
Oh, I'm gonna put the fraction.
Fraction, right? Yeah.
So I'm gonna put fraction and then 36.8
minus x or anything.
Minus m and then 8.6, right? And
is
then
equals to
and we have answer from
instead of putting 0.324, we can also put inverse norm. Can we put inverse norm?
We could put inverse norm over here, right?
Yeah, let's put inverse norm.
Right. So probability distribution, inverse norm here, right? Area is 0.7, right?
Yeah.
Good.
0, right. 1, okay, comma. Okay. That's
some function is okay. Here you go. M, right?
Comma, yeah.
Okay. Here you go. Do you see? Exactly, we got the value directly without solving, right?
Yeah.
Wonderful, right? So we use and solve to get the value, right? Without solving, right? Okay. So can we move on? And then now we found the probability. One randomly selected one could take more than 30, which is 0.605, right? And then look at this, 6 randomly chosen people complete the jigsaw puzzle. Okay, and then find the probability that at least 5 of them take more than 30 minutes to complete the jigsaw puzzle. Okay, can anyone answer what distribution we're going to use? How can we approach this question? Yay, binomial. Yes, very good.
That's the winner this time.
Yeah, binomial. Why is it so? Because each of six people, right, could be exceeding 30 or not exceeding 30, right?
Mhm.
So there are two outcomes. When there are two outcomes, that will be binomial, and then each of people will have like considered as trial. So we have 6 trial. So n is 6, right? And then
So
probably
we have fixed number of trials here because 6 randomly chosen people
yeah,
are completing. So fixed number of trials, each time probability is same. And
right.
being individual, all events are independent.
Yeah, so
And
we
we
could
have
consider
Bernoulli
that
trials,
n
so
is
binomial.
binomial 6, 0.605, right?
I've seen this kind of questions in so many exams. I think this is the
Every
most
time,
popular type,
at least one each year, right?
most popular kind of questions. Like this.
So look at this. We're gonna write down that probability x is at least 5. Okay, we need to be very careful. What does that mean? At least 5. How can we express it? At least 5.
Yeah, because if it is
5 or
continuous distribution, more than or more than equal to is same. But if it
Yeah.
is any discrete distribution, then more than and more than equal to make difference.
yeah, it makes difference, right? So
Yeah.
it will be greater than equal to 5. Very good.
5
Someone
points.
already answered correct answer, right? And then it will be much easier to find out CDF, right? So 1 minus probability, right? X is, what should I write over here? What should I write? Okay, strictly less than 5, right? Because you are including 5 the other side, right? So that means it will be 1 minus probability x is less than equals to 4, right? Right. And then I'm gonna go to my. By the way, I will save this probability, right?
But Mari, out here there are only 6 trials. So when it says more than equal to 5, don't you think 5 and 6?
Oh, 5 and 6, right? We could
Will
do
be
5
like more convenient.
right? Okay.
Yeah, but I also prefer what you're doing because this is like a special case. Otherwise,
Yeah, because
usually
you know,
number of trials is a lot.
if you want to do 5 and 6, and you need to make like CD PDF
We
5
can
and
use
PDF
PDF.
6, right? So let's see, 1 minus, right? I'm gonna save the P already, right? So here I'm gonna go probability distribution, and I will go to binomial CDF, right? Binomial CDF. Number of trial, we have 6 of them, right? And probability, I saved it as P, and then up lower bound and upper bound as 4, right? Why we are doing 4? Because 5 is not included. 5 above is considered as okay, right? So then we have probability here as no, I got the wrong probability. I should get 0.6. Okay, so let me go back again.
Okay.
Right.
Yeah. By the time you correct this, Anjan Kumar Chaudhary, for part C, do we need to work with 1 minus probability of this, or can we work on GDC with more than 30? See, Anjan, what happens is like in new calculators, you have an option of writing 30 and infinity as your upper bound. If you see in old calculators, CDF was only less than a particular value. So you can use both ways, either that way or this way. You'll get the same answer.
Yeah. Either way you feel
Either way is good.
right.
And Richard, yes, the recording will be shared, definitely.
Yeah. Okay. And then now let's move on to next one. Having spent 25 minutes attempting the jigsaw puzzle, a randomly chosen person had not yet complete the puzzle. Find the probability this person will take more than 30 minutes to complete the jigsaw puzzle. So here we need to read it very, very carefully. Having spent 25 minutes attempting jigsaw puzzle. What does this 25 minutes, right? And later on, it is asking what is the probability the person will
Yes,
take.
Arif, you're right. Arif says, looks seems like conditional probability. Absolutely.
Yes, it is. Yeah, wonderful. It is conditional. So it is like probability, right? Let's say, right, a person taking greater than 30 minutes, right? Greater than 30 minutes, given that, right, it is already greater than equals to 25 minutes. Is it? Right? So we know that probability A given B is going to be, probability B is going to be denominator, probability A and B is up there, right? So in this case, right, probability that X is greater than equals to 25 is denominator, and the up is probability X is greater than 30 and X is greater than equals to 25. And you know that their intersection is going to be 30 minutes, greater than 30 minutes, right? It's obvious that it will be greater than 30 over here, right? So it will be greater than 30 over greater than equals to 25. In fact, as Jalaj mentioned, that 25 greater than equals to or the just greater will be the same, right? So we know that the 30 greater than 30 is 0.605, right? And we could just find the 1 minus probability X is less than 25 over here, right? And let's see, we're gonna go into the calculator. So sure, 0.605, which is greater than 30, right? 605, right? And this bottom is going to be 1 minus normal CDF, not inverse normal CDF. And upper boundary is 25, right? And then mu is mu, right? And sigma is 8.6, right? Okay, here you go. So now we got the value, right, as 0.0755, right?
That's
okay.
Great.
All right. So this is very simple, but very typical IB question.
Yeah, this is typical IB question. And like Shraddha mentioned, it's a typical question that starts with normal, includes binomial, conditional. Yes, it
and
was.
then conditional distribution, right?
That's wonderful.
Okay. Now I'm gonna hand it over to Jalaj for number 2.
Great. Or
I will stop sharing, right?
yeah, you can do that. Okay, so question number 2, if you see in your resource, this thing, question number 2. Second question is, this is the question. Oops, here. I think it's too small, so I'll just read it out for you. The weights of apple on a tree can be modeled by normal distribution with a mean of 85 grams and a standard deviation of 7.5 grams. Find the probability that an apple from the tree has a weight greater than 90 grams. So it is a very simple 2 marks question. So the weight of apple on a tree can be modeled by normal distribution. I suggest, and I strongly, I firmly ask my students also, they must define a random variable. So they may write, let X be the random variable representing weight of an apple from that particular tree. So we have to find the probability that X is greater than 90. And what we have been given is the mean is 85 and the standard deviation is 8.7. So going on, let me insert. We are here. So let me insert a new page, a simple calculator page where I can do some simple normal distribution here. And since it is given, it is a normally distributed variable and the mean is given 85 and the standard deviation of 7.5. So we don't need to do anything actually. And by the way, we can access to the distributions either from probability or from statistics. So I'll enter from probability, go to distribution. I'm looking at normal CDF, go to normal CDF. In normal CDF, your lower bound is negative infinity. So what I'll do is I'll just cut this so that I can use it later. I'm looking at greater than 90 grams. So my lower bound will be 90 here and my upper bound, I'll just paste it and I'll remove this negative sign. Or I can do a big number also, I'll get the same answer. And what is mu here? Mu is the population mean, that is 85 grams. So this is 85. And the population standard deviation is given 7.5. Moment I say, okay, this is my answer, 0.252492. And IB expects all answers to be rounded off to 3 significant figure. So it will be 0.252. So this is part one, very simple, straightforward question. We don't need to discuss much on this. Let me know if we need to discuss anything here. And Marie, can you please take care of the chat? There is one new chat there.
Yes, so far good.
Okay, so if there is any thing relevant, please let me know. Otherwise,
I always learn something from you, right? And it is really clever that you use that negative infinity value, copy that and use that positive infinity. That's really clever.
Thank you. I'm lazy, so I do all these shortcuts. Okay. Now, second part of the question is, let's see if we can read from here. A sample of apples are taken from 2 trees, A and B, in different parts of orchard. The data is shown in the table below. Weight of apple from tree A is here in grams, and weight of apple from tree B is in grams here. So there are 2 different trees. And if you see, this is something special here. The number of trees is different in both sample. From tree A, you're taking 1, 2, 3, 4, 5, 6, 7, 8. Sample size is 8, and from B, it is 7 only. So the owner of the orchard wants to know whether the mean weight of apple from tree A is greater than the mean weight of apple from tree B. So he sets up the following test. H0, that is your null hypothesis, is mu naught is equal to mu A is equal to mu B, and H1, that is alternate hypothesis, is mu A is more than mu B. So the owner would like to test whether the mean weight of apple from tree A is more than that from tree B. Find the p-value of the owner's for the owner's test, and the test is performed at 5% significant level. State the conclusion of the test, giving a reason for your answer. Okay, now, as we discussed before, this is a t-test. It should be a t-test because you're given only data. You have not been given any standard deviation, population standard deviation or variance, right? So we will be using a t-test here. We have 2 samples here. So are we going to use 2 sampled t-test here, or are we going to see the difference? So is it a paired or non-paired? Anyone would like to share quickly?
I was asking what, non-paired. Okay, good. That's correct. Yes,
it is a non-paired because these are 2 independent trees. So, and we are not, always remember that keyword for the paired test is same sample is tested more than once in paired. If sample is different, blindly go with unpaired one. So this is going to be your 2 sample t-test that is unpaired, right? So we go back to the calculator and see what do we do. And if you see here, this is the data from tree A and tree B. And from tree A, we have 90, 85, 84, 79. Let me cross check once more. Finally, one more. Okay. Once more, it is done. Right? Now, we are going to test whether the mean weight from tree A is more than that from tree B. So how do we do this? We go to simply menu. And this file, this TNS file is already there in your resource folder number 1. So I suggest if you're using your emulator, open this file and do it with me and see how easy and how interesting is this. So we go to menu. Now, when we do any test, that test is only available in statistics. So go to stats and we go for the test. Now, what kind of test are we doing here? T-test or 2 sample t-test? Marie, which one should we do? 2 sample or 1 sample?
It's 2 sample.
It is obviously two sample because those are two independent samples. So we go to two sample t-test. Now, what do we have? Do we have data or do we have stats? Stats means when you have some information like what is mean, median, standard deviation and all. We don't have that. We have data, we select data. Okay. Now, once you do this, then you are asked these information you need to put in. In list one, what do you have? Which is your list one? You have to select. So you can see here
3A, right?
3A. Now, how do we get this? Let me quickly go back and show you. It won't take long. And this is something worth knowing. Okay, you see, we had 3A here and 3B is here. It is always advisable that you must label your, what do you call this? Columns. Okay, you must always label your columns. So we go back to menu, go to stats, stat test, two sample t-test. Now in this two sample t-test, we are using data, and your list one is here that has 3A, and in list two, where is list two? It has 3B, and the frequency of each of these is 1, 1. Now, what is as Marie discussed before, null hypothesis is always there is no change. There is no change. Like in physics, we have a law of inertia. There is no change. So similarly, out here, we have null hypothesis. There is no change. And what is your alternate hypothesis? The owner would like to know if the mean weight or say mean weight of apple from tree A is more than that from B, and A is listed in 1. So we will have mu1 more than mu2. Is it pooled or no? We will always use pooled.
Always use pooled, yes.
Pooled. Okay, and first result column is in B, but if I see, I think it was already there in B, and you can always shade your p-value also because it takes you to like next level of understanding and discussion. So just select yes for this also and save.
The first result column, okay, good, very good.
So we got this thing. So now you have like two screens merged in one. You can unmerge it by pressing Control 6. So this is your result here. Now thing is, how do we read this result? How do we make a decision? How do we analyze here? So first thing, it is a two sample t-test where your alternate hypothesis was mu1 is more than mu2. And when you go to the right, these are your values 2.3107, 0.018, and 13. Now, what are these values? If you see, you can just click and move to the left. This will give you. So this T is your test statistic. P value is your P value, and DF is degree of freedom here, which is 13. And this is your test statistic, sorry, 2.3105 and 0.0189 and so on and so forth. Okay, so we have got all these results. I would like to discuss one thing quickly. If we go back to the question was here. The owner of Archid wants to know whether this, okay, we have found this, find the p-value, we are done. The test is performed at 5% significant level, state the conclusion of the test. Now, after looking at this one, we always look at the p-value, and if the p-value is less than the significant level, then what do we do?
Reject null hypothesis.
We reject null hypothesis. Now, my question is, why do we do this? And what is why your calculator is calculating 2.31075 and your p-value is this? What does it mean? So for this, let's go back to the graph. This is a graph of your these values. So out here, your p-value is 0.0189, t-value is this, and your graph looks like this. Now, if we analyze this graph and go back to the concept of hypothesis testing, 5% significant level means top 5% will be rejected, right? So if we say 0.0189, So it means around 1.89%. So 1.89% will be lying somewhere here on the right hand side. So this t, which is 2.3108, is lying somewhere here. So as we discussed initially, we do hypothesis testing on the basis of the sample and the population. There is a population claim and there is sample observation. So when you observe using the sample, that observed sample is falling into the rejection region. So that is, in other words, we are going out of the tolerance. It is falling out of the tolerance. So we are rejecting null hypothesis. So in this case, what will be your conclusion here? If you go back here, so the test is performed at 5% significant level, state the conclusion of the test. So we have sufficient evidence to believe that the mean weight of apple from tree A is not more than that from tree B. Any discussion, anything? There are 21 chats, Marie. Is there anything which I should address?
Can you show us the t distribution and the p-value graph? That's really nice. Next one. Yes. How did you produce that?
This one. Okay. So in this one, when I did my test, okay, I need to, when I was here in my data, this is my data. So I went to menu, statistics, stat test, to sample t-test. Now, when I entered my values, when I scrolled down, there was an option shade p-value. So I just checked this.
Yeah, when you do that, it shows the side by side, right? But you separated.
It does show. It shows required field is empty, field 2. Okay, so it shows. How does it show? Let me go back and show it to you. So when you do this, then this one I can do control 4. So your result will look like this. Control 4 is to merge a window and the window next to it.
I see.
Is to unmerge them. These are shortcuts, and you can do this here also. If you go to doc in page layout, you can have like group or ungroup. Control 4, control 6.
If you do ungroup,
just press control 6. If you press control 6, these are ungrouped, and if you press control 4, these are grouped again.
Yeah. Okay.
So corresponding to this data, this is the table.
Right.
I mean, this is the what do you call this? T graph.
Okay, that's really great.
So this was question number 2. Is there anything else in question number 2?
Anyone else have any question? This is really nice. That 2 sample t-test, right?
So let me stop sharing and quickly have a look at Excel spreadsheet. Okay, so you have been taking care of this one.
Yeah. All questions are taken care of, right?
Okay, would you accept the alternate hypothesis? Yes, we'll accept the alternate hypothesis that, or you can say either we reject or we accept alternate hypothesis that average or say weight of apple from tree A is not more than that from tree B. So question number 3, what is coming up in third question?
Oh, okay.
Are you planning to discuss this?
Interesting one, right? We have the distribution is 2 different distribution is
It's
given.
getting dark here. I would like to turn on my lights. One moment. We said Tamsoma Jyotirgamay. Let me do it.
Okay. Thank you. Okay. I want to see the chat also. Okay, good. So feel free to stop me and ask me, right? And if you just type the question here, right? And tell us what might bring.
Yeah, I'll take care of this chat part if there is.
Right. Let's look at this question, right? You know, one of the things when we have this lengthy question and with the table, students are quickly intimidated. But you don't need to be intimidated. If you break down, it's not that difficult question. So let's attack. So it said Slugworth Candy Company sells a variety pack of colorful shaped sweets. The sweets are produced such that 80% are star shaped and 20% are shaped as a crescent moon. It is known that 10% of the star and 30% of crescent moon are colored yellow. Then find the probability that sweet is yellow. So what shall we do? Can anyone give me some idea? How can we do? Anyone? Give me some idea. So here, see, it is
Tree diagrams.
oh, tree diagram. Yes, I love tree diagram. Right. So it says, right, 80% are star shaped. So I'm going to put star over here, right? And it's going to be 80%, right? 0.8. And then 20% is going to be crescent, right? Okay. And among these three, among this star, right? 10% are star, right? 10% of stars and 30% of crescent is going to be yellow, right? So it's going to be 0.1 is going to be yellow, right? And then if 0.1 is yellow, right? And then other 90% will be not yellow, right? So I'm going to put not yellow, right? And 30% of the crescent, so which is 0.3 is going to be yellow, right? And 0.7 is going to be not yellow, right? Okay, how can you find the probability of yellow then? So we have two roots, right? One is going to be, so let me put this down a little bit, right? So one is going to be 0.8 and 0.1 yellow, right? And 0.2 and then 0.3 yellow, right? So the total probability of yellow is going to be 0.8 times 0.8 times 0.1 plus 0.2 times 0.3, right? Okay. And when you calculate that, that come out as 0.14, right? And then given that, here, given that switch yellow, right? Whenever you hear the word given, and what is that? What is that indicating? And it is star shape.
Yes. Anjan and Shraddha and Richard, they mentioned conditional probability.
Yeah. Excellent. Wow, you guys are so good.
And Mahesh Reddy also mentioned it's conditional. Wonderful.
Yeah, conditional, right? So given that it is yellow, it is star, right? Okay, and then as a previous question, right? So probability of yellow comes here on the bottom, probability of star and yellow, right? And then we know that star and yellow is going to be over here, 0.8 times 0.1, right? So 0.8 times 0.1 here, right? And then total probability of yellow, we already calculated from A1, so which is 0.14.
Yeah, so Anuj Goyal and Shraddha also came up with the same solution.
Yeah. So that will be 0.571, right?
Lovely.
Okay, now I'm going to attack this table, right? According to the manufacturer's specifications, the colors in each variety pack should be distributed as follows: brown, red, green, orange, yellow, purple are 15%, 25%, 20%, 20%, 10%, 10%, right? That's what manufacturer saying, right? But Mr. Slugworth opens a pack, 80 sweets, and recorded the frequency of the color and showing that brown 10, right? You count this 80 candy. Think about that. You are, separating brown, red, green, and then count it, right? But sometimes you would like to test it, right? So you want to test whether your manufacturer's claim is true or not, right? So,
Maria, I have a question here. Sorry
yes,
to
go
stop
ahead.
you, bother you. You mentioned in the beginning, initially, I remember you said this can be used only for the categorical data. So, can you show us why this is the categorical data?
That's a really good question. Why is it categorical data? Why is it categorical data? You see, the category means just same as brown, red, green, yellow, right? Or Republican, or democratic, or your eye color black or brown. Your race as like Caucasian or African American or Asian, or those things are called as categorical data. Oh, someone mentioned the descriptive. Yes, it could be descriptive one, right? Something that is not, that cannot be expressed as the continuous variable. So continuous variable is something like, blood pressure or height, right? Jalaj, then I could ask you a question. What about age? Do you think age could be considered as continuous or categorical? What do you think?
Sorry, what age?
Yeah.
I don't know. Let participants answer this.
You know, when I go to a hospital, sometimes they put the bracelet and then making it write down my age as something like 20, 21. I wish I could be 21, 21.7 or 1.8, right? And it could be considered as continuous variable if you consider that way. But sometimes instead they could, yes, it's great, it depends. Sometimes they could categorize as 20 years or 30 years or 40 years or 50 years, right? And then in that case, it is considered.
It depends on context of
in that context, right? Depends on the context, right? It could be considered as categorical. It could be considered as continuous variable. Very good, very good. Right.
Great, thanks.
Right. Thank you for pointing that out. Right. So see, chi-square test is only for the categorical data. So it's not for the continuous variable, right? So while normal distribution such as normal distribution, Z distribution or T distribution, they are continuous, but chi-square is for categorical data, right? Now, when we have these two, now we want to test, right? We want to test these two distribution. One is what manufacturer says it is supposed to be, right? And the other one is I checked it, 80 candies, right? And this is what I found, right? And what test can we use? Can anyone answer? What test can we use? What statistic we're going to use? What statistical test we're going to use? Don't be shy. We are all learning.
Sorry, Marie, what was your question?
What statistical test we're going to use when we were given this situation that one is manufacturer's distribution and the other one is I observed the distribution. Someone mentioned.
It's there in the question.
Yeah.
The sample is consistent with manufacturer's specification. We conduct the chi-square
goodness of fit test, right? So
we are doing goodness of fit test.
Yeah, goodness of fit test is testing distribution. In this case, distribution of candy, right? Right. Very good, very good. Now, goodness of fit test, we are given like this is what is the manufacturer given, and this is observed, right? So for the expected one, right? Expected one, how can you calculate the expected one? And we are following expected one based on manufacturer said, right? What is supposed to be, right? So which is, right? Out of 80, right? Out of 80, 15% must be brown, right? So which is 0.15 80 is going to be brown, right? In the same way, it's going to be 0.25, right? 25, 80 is going to be red, right? So as we calculate, right, 0.15 times 80, right, it will be coming out as brownish 12, right? And then 1/4 of 80 is going to be 20, right? Same way, right? And 1/5 of 80 is going to be 18, right? And then 20% of 80 is going to be 16, right? And 10% of yellow, 10% yellow will be 80%, 80 out of 80, 10% is 8, right? 8, right? So are we all clear about the expected number? Yeah, very good, right? So we have observed the number, observed value, right? And the expected value, right? Now we're gonna go to goodness of fit test, right? We could use over here, or we could use in the calculator, right? I'm gonna use over here, right? And we're gonna go to menu, right? And statistic, we're gonna go stat test, right? And then we have, see, remember the chi-square has two tests, which is goodness of fit, or two-way test is independence test, right? Goodness of fit, right? We are going to go observed, right? And then expected, right? And here, oh, degree of freedom. How can you know the degree of freedom? In this case, degree of freedom for the goodness of test is category -1. So how many category you have? 1, 2, 3, 4, 5, 6 category, right? 6 category -1, which is 5, is the degree of freedom. So
it's n-1 here, yeah.
5, right? And okay, I'm gonna use shaded p-value, right, over here. Right? Whoa, so we have, right? Let's look at this, right? Chi-square value is 4.58 and p-value is 0.468, right? 469, right? And degree of freedom is 5, right? What we wanna see most is this p-value. P-value is shaded over here. Do you see the chi-square and p-value is showing over here? Let's look at this big one. So big, so was it control 6, right? Right. So look at this.
Control 6.
Yeah. So 46.9% is over here, right? And
sorry, I have a question here.
Yeah.
State the conclusion, giving a reason for your answer. There is no are you given any significant level?
Yes.
Sorry. It's given.
Yeah. There's no significance level, right? Usually it is given as significance level.
It is given here. Sorry, my bad.
Something like that, right? But it is not given, right? But let's just assume the extreme, right? What about 1%? No, 1% is 0.01, and this is way big, right? And what about 5%? 0.05, it's way bigger than 5%. And even if we consider that it is greater, like as 10%, right? So our error is, the rejection reason is 10%. It's way greater than anything, right? So we can say that, right? We can say that we will accept, right? Accept the null. Accept the null. Oh, so here, what is H null then? What is H null? H null is there's no difference, right? So which means the distribution, right? So the manufacturer's distribution, right? What manufacturer said the distribution of manufacturer's specification is, right, same as what is observed. Right. So
that is great.
Yeah, that's the null hypothesis. So we failed to reject null hypothesis. So we accept that they are safe, right? That's the conclusion. Yeah.
Can we find expected frequencies using calculator?
Yeah.
Yogita is asking.
In this case, right, expected value, I just like simply calculate that the 15% of 80, 25% of 80.
Okay, so out here, yes, Yogita, we can find in both tests, we can find out here. If you're doing it this one, you need to define your formula. Like you do this in Excel. So in this formula field, you need to define. When you are looking at like maybe a goodness of fit using binomial distribution, in the definition formula, this thing field, you define how your expected frequency are expected. So you can do that. And when you're doing like test of independence, that automatically comes, that automatically appears.
Yeah. And remember someone was asking how to put the value, right? Type it, right? Type the name of the list, right? So here is a type the name of the list. You could just use here.
Yeah, just double click and type.
Yeah,
Mari, there is a very good question here. This gentleman Bhuvnesh is asking a question. Do we use the word accept H0 or do we use do not reject?
Oh, both of them are accepted. Both of them are accepted.
So I think Bhuvnesh, this question leads to a new concept that is called type 1 and type 2 error. Are we discussing type 1, type 2 error, Mari, today?
Okay, anticipating, like you are going to have the Independence Day special, which will be given like August 14th, right? John?
I don't know. I'm not sure about that.
Yeah.
So
we are going to discuss about type 1 error and type 2 error.
So we are not discussing type 1 and type 2 error, right? Yeah. Today. So Bhuvnesh, stay tuned, and soon there will be another webinar, and on like maybe part 2 of this. So there we will discuss about type 1 and type 2 errors. And your question, do we use the word accept or do not reject? My suggestion would be we do not have sufficient evidence to reject H0, hence we accept H0.
Yeah.
So this is same actually.
Yeah. Good. Yes.
And John, yes, rightly said, Marie is going to explain this on another day. Yes, another day.
We're going to do type 1 error and type 2 error. Be anticipated. Yes. Okay.
That's
all right.
great. Thank you so much.
This question is quite lengthy, and Jalad will be leading us, right?
Oh, sure. Definitely. Yeah. I would love to. Okay, so next question. Let me start sharing my screen. Okay, everyone has this question. So I'll quickly read through this question and let's see what are the important parameters we need to remember here. Our two IB schools, A and B, they both follow the IB diploma program, but had different teaching methods. A research group tested whether the different teaching methods lead to a similar final result. For the test, what kind of test, we don't know yet. For the test, a group of 8 students were randomly selected from each school. Both samples were given a standardized test at the start of the course, and a prediction for total IB points was made based on the test. This was then compared to their points total at the end of the course. Now you see, where are we heading? We are going to test the same sample twice. Once at the beginning of that process, beginning of that program, and then at the end of that program. So which test it seems now? Which test are you sharing? Am I not sharing my screen? My apology if I'm not. I think I'm sharing.
Oh, we can see your screen well, don't worry.
Mahesh, I'm sharing my screen, Mahesh, just check your settings. Okay, so since we are conducting, or say we are testing same sample twice, there are 2 samples and both those samples are tested twice, once at the beginning and then at the end of this IB course. So what kind of distribution are we looking at here? Marie, any answer here?
Yeah, someone said t-test paired.
T-test paired, okay. So what kind of the test is this? Two sample t-test or 1 sample t-test?
Okay, can anyone answer? 2 sample? 1 sample? We have two answer. One is 2 sample, the other one said 1 sample. What would you say?
Okay, so see, in 1 sample and 2 sample, actually, this is quite ambiguous. There is an ambiguity in this question initially at this level, because I said there are 2 schools, so obviously there are 2 samples. And each sample is tested twice. So when we look at each sample is tested twice, it is 1 sample. And when later, if we compare, I don't know if we are going to compare, I haven't seen the later part. If we compare 2 schools, that will be 2 tests. So the best thing is to avoid this confusion. Let's read it. Okay, so previous results indicate that both the predictions from the standardized test and the final IB points can be modeled by a normal distribution. Wonderful. It can be assumed that the standardized test is a valid method for predicting the final IB points, and that variations from prediction can be explained through the circumstances of the student or school. Fine. Part A, identify a test that might have been used to verify the null hypothesis.
Do you can you show the questions? Now you are showing the TI calculator.
Yeah, actually, this is a big question, and everyone has this question in their this resource pack.
Oh, I see.
So that is why I was not showing.
Okay.
I can see it must be somewhere here. No, it is not here.
It's okay. It's okay.
I think they all have access. Let them read from their pack. So part A is identify a test that might have been used to verify the null hypothesis that the prediction from the standardized test can be modeled by a normal distribution. It's a very interesting question. Anyone? Which test might have been used to verify the null hypothesis that the prediction from the standardized test can be modeled by a normal distribution? When you claim that population is following a specific pattern, means they are fitting into a frame. What kind of test do we use? Anyone? Chi-squared goodness of fit. Wonderful. Indrani and Nandini.
Yes, chi-squared.
Probability, one with I, one with E, Y. So that's correct, absolutely. So since we are going to test whether a normal distribution can model this, so is data fitting into the normal distribution? So we go for goodness of fit test. Absolutely. Thank you so much for sharing this. So chi-squared goodness of fit test. Part B, state why comparing only the final IB point of students from the 2 schools would not be a valid test for the effectiveness of 2 different teaching methods. When you compare only final IB points, why is it not a good method? Okay, state why comparing only the final IB points of the students, okay, from 2 schools would not be a valid test.
That's a good
effectiveness. Listen, look at this. For the effectiveness of the 2 different teaching methods, we are talking about effectiveness of 2 different methods. Method means we are talking about the process. So when we look only at the final result, it won't provide like how effective was the process. If you say that somebody used to get a 3 in HL maths, because of your teaching, that child is getting a 7, it is justified. Or the child used to get a 3, and now because of your teaching, the child is getting a 6. Brilliant teaching. Child used to get a 7, because of your teaching, he's getting a 6. So it is not justified if you only look at the final result, right? So that is why process becomes important. So this is 1 more question.
Jalaj, someone mentioned that the teaching method and students' capability may vary. This is a good point.
May vary. Yes, but like out here, see what we are testing here is if we read this question again, and remember this is 1 mark question, and it says, would not be a valid test for the effectiveness of two different teaching methods. If you look at this. So whenever we talk of the teaching method, we are talking about the process. In the process, we can't just consider the end result.
So
we
you want to see
need to
the difference
consider
between before and after, right?
Yes, we need to discuss that.
Yeah.
Right?
Right.
Okay, let's move on. Yeah, it's a big question, so let's move on. So the data for school A is shown in the table below. I'm sure everyone has that table. It is like this. The student number is 1 to 8. Gender is male, female, male, female, female. And predicted IB point is 43.2, but the final IB point is 44. There is an improvement. Prediction is 36.5. Prediction is 34. There is a drop here, and so on and so forth. Okay, so moving on. For each student, the change from the predicted point to the final point F minus P was calculated. Find the mean change. So now we have already got this data listed here. So this is question number 4. Okay. So in 4th, this is PRED's predicted grades, and this is final grade. And so what we can do is we can find the difference here. So how do we, difference also, okay, we have already found
difference
here.
of A. Difference of A is the one that you need to find.
What is this difference B?
Difference B is next question.
Okay, difference B is next question.
Yeah.
Okay, so difference, this I have to find. So we have to find this difference, the predicted, final minus predicted. So F minus P. So Yogita, this may give some hint to what you asked before. Can we define the expected frequencies, right? So out here, how can we define? You see this formula field here is equal to, so here we can define.
Okay.
So difference A is defined as, how do we define this as? Final minus predicted. So you can do just like Excel, Microsoft Excel. Either you can write B1 minus A1 and pull it down. Otherwise, you can go to variable. You can see a final minus, go back to variable, predicted, and enter. The moment you enter, everything is displayed here.
Yeah.
Right, so either you can do this way, or you just do B1 minus A1 and hold the corner, pull it down like we do in Excel, and it will be there. So we have this difference. Now remember, where is your difference? Difference is in D. Calculate the mean change. So mean change, so we do the usual work, data, go to stats and stat calculation, one variable stat. Number of list is 1 here. You can say, where is your list? It is in D, frequency is 1. Okay. And overwrite, just overwrite. I don't know what was there. Okay, so this is your mean 0.1875. So 1875. So when you do it correct to 3 significant figures, it can be 0.188, right? Okay, next part is find the standard deviation of the changes. Now, there are 2 standard deviations here. If you see, one is 2.6, this is standard deviation as X, and this is sigma X, 2.46 and 2.63. Which one are we going to take? Anyone?
We're gonna use the standard deviation of the change. Someone said sigma X.
Sigma X. Why? Yes. Why do we use sigma X? Why not SX? That's correct. Absolutely, it is sigma X. Shraddha,
Sigma X,
right?
population, and SX for sample.
So, this is like very, very interesting topic to discuss. when it says the question, it is very important to see what question is asking. Find the standard deviation of the changes. So we are looking at the standard deviation of the changes, means of that particular data. Whenever we find standard deviation, we need to ask ourselves, are we going to use it somewhere as population standard deviation? If we are going to use it as population standard deviation, like especially when you find the confidence interval, or you do this testing manually, or when you discuss about the distribution of sample mean, distribution of population mean. So at that time, we need to see if the standard deviation will be used somewhere as population standard deviation, then we need to use unbiased estimation of the population standard deviation. That is a bigger value. Otherwise, 2.46. Great. Thank you so much for sharing this. Okay, moving on. Use a paired t-test to determine whether there is significant evidence that the students in school A have improved their IB points since the start of the course. Now, we are using a paired t-test here, right? Because we are taking two values. So we are using paired t-test. But remember one thing. Since we are doing this is called matched pair when the same sample is tested twice, right? So we will not use two samples. We can use one sample. And how do we know? Like, once again, it all depends on how question is asked. Use a pair t-test to determine whether there is a significant evidence that a student in school A have improved their IB points. We have found the difference. If the difference is consistently positive, it means the students have improved. But if we look at the difference, it is 0.9, negative, negative, positive, positive. So we are doing a testing, because whenever you have a doubt, test it out, right? So this difference we will test with the help of t-test, and that will be one variable t-test. So how do we do this? Let's go to stats and stat test. And let's do it with t-test. Now in t-test, what do we have? Do we have data, or we have stat? We have a data here, right? So press, we have data. Your mu naught. So out here, what is your this thing? Null hypothesis. Your null hypothesis will be there is no improvement. Law of inertia. Always remember that there is no improvement is null hypothesis. And your alternate hypothesis will be there is an improvement, right? Now, mu naught, what is mu naught here? What will you write for your mu naught?
Mu naught is going to be 0. Yes, someone said 0. Yes, yeah.
Let's put 0. And where is your list here? Where was the list? Difference A?
Yeah, difference A, yes.
We are analyzing difference A. The frequency is 1 each, and your alternate hypothesis is what? What are we looking at?
We are looking at the improvement, so it's going to be greater than 0.
Greater than 0.
Yes.
And your column is in D. And I would like to shade the p-value also here. Shade p-value and okay. So if I do okay, I see something like this. So let me separate them and see how it looks. Where is my G? G is here. So 201586. I think this should be a p-value or t-value. Sorry, this is the t statistic. And your p-value is this.
0.422.
P-value is, wow, 42.29%. It's so big, so big. It's really big. And 7, what is 7? Is the degree of freedom? Yes, so degree of freedom is 6. So we got these statistics. So if we read the question again, we go back to question, use a pair to, okay. Okay, this is very interesting here. See, use a pair t-test to determine whether there is a significant evidence that the students in school A have improved their IB points since the start of the course. Now, if you look here, if you see here, there is no significant level given here. 5%, 10%, 1%, it is not given. So what should be your analysis here in this situation? Anyone? I would like to hear from participants. No differentiation. Okay, maybe. Anyone? How should we make a decision here? There is no significant testing given here. I mean, significant level given here.
I mean, just similar to the previous one, because
Yes.
we don't know, but we can think of like even maximum 10%, right? Even if it is 10%, the 40% is way bigger than 10%. So
Yeah.
we could easily come up with come to the conclusion.
So can we say like in any practically possible significant level? If you read your IB guide, clearly it reads you are supposed to use 1%, 5%, or 10%. Use the popular significant level. And this is something which is like beyond all practically possible significant levels.
Yeah.
Nobody will tolerate this up to 50%. Even if you're buying a sack of coal, or maybe some stone for construction, 50%, 42% significant level is not tolerated in any situation. So you can say like considering the very high value of p value, which is how much was this? Let me see it again. 42.3%.
0.3.
So at any practically significant tolerance level, we have enough evidence to claim that
There's no evidence
that result have not improved.
Yeah. Good.
Right? Yeah. So we have to accept the null hypothesis. Great. Any question, anyone? Any comments, any suggestions?
Someone also mentioned the p-value is very large, insufficient evidence.
Absolutely.
Yes.
Okay, so this was part C or D? Part D.
That's D.
D. Oh my God, there are more parts here. Okay. The data for school B is shown in this table below. Okay, now we move on to part the school B. In school B, you have been given only the difference. The final IB point, predicted IB score, F final minus previous predicted is given here. Use an appropriate test to determine whether there is an evidence at 5% significant level that the students in school B have improved more than those in school A. This is very interesting. So what are we doing here?
We have two samples, right?
Yes.
We have school A and school B.
Now, the question says whether there is evidence at 5% significant level that the students in school B have improved more than those in school A. So are we comparing two independent samples here?
Yes, we can consider that independence. Yes.
Okay. Otherwise, what else can we do here?
Two sample, right? Two sample, and also it is given that
one of them are two sample t-test. Yeah, it sounds like the most sensible thing to do here. Thanks,
one tail, two sample t-test. Right. Very good.
So let's do it. And where is our data? Can we check it once more before we continue? So we have to look at
you overwrite. It was on E, I think.
Did I?
On E, and you overwrite, but
did I? Okay, no problem. What I can do is I can just do Control Z. I'm doing undo.
Oh yeah, it's over here. Yeah. Okay. Somewhere I saw it. Okay. 42, and then difference B. Yeah, over there. That's
I can quickly find difference A here. Difference A is equal to my final
minus predict.
Final minus
predict.
Predicted and enter. Okay, so now I have data from D and E. Now I have to see whether what is my question again? Let me read it again.
School B is greater than
100 times. Still, you are really clear what you're doing. Keep reading your question. Okay, at 5% significant test, the student in B have improved more than those in school A. So our alternate hypothesis will be the mean of B is more than that from A. Am I right, Mary?
Yes, you're right.
B is more than mu A. That will be my alternate hypothesis here. So I go to table. Why should I go to table? Let me go to statistics, stat test, two sample t-test, as Indrani mentioned. I have data here. What is my data? My list one is in, where was it in? C. I don't know. So let's check difference A, and list two is in difference B. Frequency is one each. My alternate hypothesis is mu1 is less than mu2, right?
Yeah.
Is it
Less.
What should we do with pooled? It is always yes when you are doing IB. A result is in E and shade your p-value. Yes, 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 just do yes. And there you go. If you do control 6, you can see they are moved, or this time let's discuss from here. Is there something wrong I did, or no, it seems good. So your p-value is 0.0984.
Yeah, you're right. Yeah, because it's going to be, mu2 is greater, right? So that's why your tail is on the left hand side.
Yeah, so when this is 0.0984, is it more than 0.05? That is 5% significant level?
Yes, it's greater than 5%.
Where should be your test statistic here?
Mm-hmm.
It should be somewhere in this white area.
Mm-hmm.
Negative, so obviously on the left of 0 and on the right of this mark, which is the critical point. So it has to be somewhere here, right? And we have sufficient evidence to accept null hypothesis, do we?
Yeah, accept null hypothesis. Yes.
We accept null hypothesis here. And what was our null hypothesis?
Yes.
There is no difference.
No difference.
Yeah.
Between school A and school B.
H naught, mu1, mu2, two sample t-test, one tailed. Mary, okay, this you wrote it. Sorry, yeah, great. Thank you. Okay, any question, any discussion until this part? Anything which you like to add here or discuss here? And of course, when you go back here, then you can see all these values are your p-value, your test statistic, and everything is here. And of course, you can always take it the screenshot, and if the students are doing it in their not portfolio, their exploration, they can do use a screenshot and use it. Okay, so E part 2, state why it was important to test that both sets of points were normally distributed.
Why it is important?
If you look at the sample size, what was the sample size?
Sample size, both of them are 8.
Yes, it is not actually big enough to use central limit theorem, I would say. That is why we have to assume this is normally distributed.
Yeah. So there should
be. We have 2 more parts of this question here, but when I looked at my watch, we are almost, we have just 50, say practically 13 more minutes left. So Mari, do you want to, should we continue or should we stop here? And
maybe we can open up some discussion if they do have any question.
And similarly, maybe like, participants can try the other questions. And if they find out, you're most welcome to contact us. Any of us.
Hello, good evening. I just need a reminder because I haven't gone through the topic now for more than maybe 4 or 5 months. That's why I need a reminder that when do we use the one-tailed or two-tailed test, or is it one sample or 2 sample test? Very basic one.
I see. That's a good question. Yes.
Mari, would you like to address this?
All right. So when do we use one tail or two tail, right? Remember the previous question? It was specifically like, can I present the previous question just quickly, right? Yeah. So if you look at this question, right, it is saying that use appropriate test to determine whether the evidence at 5% significance level that the students in school B have improved. So here the key word is improve, right? So improve means positive difference, right? Because we did, right? What we did is final minus predicted, right? So positive difference is greater than the school B is greater than BA, right? So in that case, when we choose that alternative hypothesis, we choose as greater, right? So two cycle t-test, we're gonna choose. So from here we choose the school B is greater than school A, right? And then when we do that, do you see that? Right? When we do that, that is one tail. So two tail means not equal to. So if you say not equals to, then 5% significance level is going to be split into two as, so let me try to draw the normal distribution, right? So see, this is two tail. When you have 0.025 here, 0.0025 over here. So their sum is 5%, right? And one tail, right? In this case, one tail, 5% goes over here, 0.05, right? One side, right? And that's the case of one tail. So how do you know which is, see, this is two tail, right? This is two tail, and this is one tail. How do we know which is two tail or one tail? Whether it has indication of greater or less in the context, right? In the context, greater or less, that's one tail. If there is no greater or less, you are only testing it is different, then that's two tail.
So two tail we'll use when there is no difference. That you mean?
Okay. Add to little to that. Take an example. Let's say you have a phone, right? You bought a phone, and the phone company says, without charging this phone, you can use it for 20 hours. But when you start using, you realize that after 10 hours, battery drains out, right? So it means what company is saying is, you're not happy with that. So you would like to test. And now this time, what will be your plea? What will you say? That what you are saying is wrong. Your mean is less than what you are stating, right? So this is one tail test because this is overstated. Now, secondly, company gives you a charger. Company says if you use this charger, your your battery will be full in 2 hours. But when you plug it in, it takes 4 hours. Sometimes it takes 5 hours. So again, you start suspecting that what company is claiming is not correct. I'm taking more time. So according to you, the mean is more than what company is claiming. So it is again a one tail test on the upper side or a lower side, right? Now, let's say you are working in a place where you need to go from town A to town B, and you go by bus every day. And officially, it says that bus should take 30 minutes, but sometimes you see that bus takes 25 minutes, sometimes bus takes 35 minutes, sometimes it takes 40 minutes. So you would like to test whether the claim of the bus company is correct, that it will take 30 minutes. So you're not sure whether it is more than 30 minutes or it is less than 30 minutes. So what will be your hypothesis here? Not equal to 30 minutes. It may be more, it may be less. So this is two-tailed. Marie, is it making some sense what I said?
Yeah, sure. So it always goes by the alternative hypothesis. So when the alternative hypothesis said not equals to, then that's two tail. If it is greater or less, right? And that's one tail.
Yeah.
Clear.
And it's very important to read question very carefully.
Yeah.
Sometimes it appears it is a one tail, but you have to see what question is asked. When they ask you to investigate.
So if it is said that they are not same, but when we are not sure whether it is greater or less, then it will be two tail.
Yeah. So
absolutely.
when the question indicates no increase or no decrease, right? And it only mentioned that not equals to, right? And that's two tail.
But in this case, they said, what about in this case? In this case, what are they saying? That
It
the
is
students
saying
school
that
B have improved more than school A.
more than,
So it will
right?
be, that means it is one tail.
Yeah, it's
Yeah.
one tail because he said more than.
So it has specified which one is more and which one is less.
Oh, it
Yeah.
said
That's,
school B is more than school B, school A.
that means that's why it is one tail, right?
Yeah, that's why it is one tail. Okay.
Thank you.
Anyone else?
Anybody else? Any other question?
Yeah, I really like this discussion.
Yeah.
What about one pair and two pair? Is it like different thing or?
Sorry, Mobin, could you please come again?
So one is one tail and two tail. What is another thing? Is it two pair or two sample or one sample, something like that? Or
Oh,
maybe
so
if
see-
there are two. So if there are two tables, that means two sample. If one table, there's one sample, isn't it?
Not necessarily. See, if you're testing same sample twice, it can be one sample. It can be considered as one sample. You take the difference and use one sample. If you're taking two independent samples, then it is two.
The line was the connection was breaking. Could you please repeat what you just said? I could.
Okay, I said if you are testing same sample more than once, if you're testing same sample twice, so that test may be considered as one sample where you can see the difference. But if you are testing two independent samples to compare them, that will be two sample. So today's this thing solution of all the questions plus all TNS files plus some important things are here in this folder. This is resource folder 2. It has a step-by-step solution of all the questions which we discussed so far, plus solution of those parts.
Yeah. Also there.
Plus TNS files of all the questions. All the questions are there. And some summary of the tests is there. And if you have any question or any, like, if you like to discuss anything.
It is asking for access request.
One
Once we
more.
clicked in, it's requesting that.
Oh, okay. So I will give the access, right? Don't worry. Okay.
No, I think anyone with the link can have access to this. Let me share it once more.
Okay.
It reads.
No, Jalaj.
Oh, yeah.
Don't
I
have the
changed.
access.
I
Okay.
just changed.
Can
So
you
please,
again?
Yes, now we can
Right.
have the access. Yes.
right. Can you try again? Is it working?
We can access now.
Yeah, it's
Yeah.
okay.
Thank you so much.
Yeah.
Okay, so any other question, Hassan?
One question is there, I think, from Anjan. As you can see, if no significance level is mentioned, what is the level that we should check for significance?
See, usually it's if it is more than 2%. When there is no significant level given, then there is a very, very high chance that the p-value will be very high. And you can say that at any practically possible significant level, or say commonly used 1%, 5%, 10% level, this p-value, wherever it is fitting, you can mention. And otherwise, like if they ask you to investigate your analysis, and your p-value is, let's say, 2% or 3%, then you can say at 1% we will accept, 2% will reject. You can do those things, but I don't think that that sort of discussion they'll ever ask. So if significant level is not given, then just say at any practically possible significant level. This is my prediction. And always remember, in stats, everything is approximation, all is estimation. We both may have different answers and we both may be correct. It all depends upon how do we analyze. Am I right, Marie?
Yeah.
Can I get recording of intro section, Anju Goel? Anju, you will be getting a full recording and Hassan will take care of that.
Yeah.
Starting till end.
Any other question? Like anything? Like how does student feel about statistical tests? How do students feel statistical tests? What is the difficulties that students have in your experience?
Maybe the reading instructions.
Yeah,
or,
reading
you know,
instructions.
they get mixed up.
Yeah, you need to read really carefully. Yes, right. And which test to use? Yes, that's really important, right? Remember in the beginning, we were talking about what is the difference between Z and T, and one sample or two sample, or whether it is paired or not paired, or even goodness. So when do you use chi-square? Chi-square is used only for categorical data, right? And when it's used for goodness of fit or the independence test, right? So we only restrict, right, our contents for the IB questions and IB tests. In fact, there are way more complicated statistical tests, but we want to focus on IB contents only. So if you stick
there is a question from,
yeah.
Sorry, Oliver, which test to use and making conclusion? Oliver, depends upon the question and the content. So we can't like decide.
Can you unmute your mic and then ask? It's okay.
Yeah, can you, Hassan, could you please unmute everyone?
Yeah, everyone is unmuted.
Mr. Olive, you can
Hi.
speak up. Hi.
No, just the problems of the students when let's say they have problems in choosing which test to use, and then when they have those numbers, they have difficulty in making conclusions.
Sorry, I thought it was a question. It was a response.
Yeah, yeah. You're saying that, you know, which test to use and making conclusion is their difficulties. Yes, you're right. Yeah. And statistics is pretty complicated, but the good thing is, as you have seen today, right? Everything could be done readily, like, you know, function is already in TI-inspired calculator. So as long as we verify what information is in the question, right? And put it in the right place, right? And everything is coming out, really. It's like a magic for me, right? And when I was in graduate school, I was doing a lot of the proof. And no, here, you don't need proof. You just need to understand and then put the data in there. The magic comes in TI Inspire. So that's something that I love about TI Inspire.
True.
Yeah.
Question from Mary. How do you encourage students to choose MAI if the popular option, whether right or wrong, is a different question? Let's go to MAA.
Okay. I don't know. Okay, John. What do you mean by that? How do you encourage students choose MAI? Okay. Here is wrong perception. I believe that it is wrong perception, right? That most of people believe that, oh, the MAI is less rigorous than MAA. I don't think so. When I look at the questions of MAI, HL, especially HL paper, it is pretty challenging. It is very challenging. But what I could encourage my students, right, as a person who studies statistics is everywhere. It's really everywhere, right, Jalat? It's everywhere. And what I am telling my students, right, these students who are studying, right, like, you know, those calculus, like, you know, the L'Hopital's theorem or whatever, Taylor's series or whatever, right? They don't understand what they are doing, but at least students, right, who are doing statistics, right, MAI, they are doing something more practical. See how practical we have.
Marie, I don't disagree. I don't disagree whether it's the rigor regarding the rigor or my question was directed on, see, for whatever reason, there is a certain perception. How do you manage to then change that or steer that or encourage students, despite, kids at that age want to take what is popular or what their other friends are taking, but knowing the children from maybe from 9th standard and 10th standard, how do you help them to, continue with statistics? What do you say? What do you do?
I mean, I have a lot of story. My case, I was helping the introduction to biostatistics in LSH Science Center, and there one of my friends, right, who came from Los Angeles to Louisiana to take master's degree to become nurse practitioner, NP. It required biostatistics, and she needs to pass that. And the biggest challenge for her was mathematic part, right? And she was confessing that I didn't know that this statistic is that important to my life until now. And she was 40. She was 40 and she studied that master's degree, and then she was frustrated in statistics. And the more she understands, gradually she appreciates more of like statistics. And I have a lot of friends who were struggling in graduate school only because of statistics. Because when they want to publish their thesis, right? What is the biggest challenge? You need statistics. If you don't have statistical idea, right, you can't pass thesis or dissertation. My husband did linguistics, and yet he needs statistics. Statistics is really, really important, and it is really useful. And I think the usefulness of statistics is getting more and more important.
Jalaj, I have asked you also a question.
Question: how did you manage to stay so young? I celebrate.
I know the secret.
Yeah, I'm young actually. I'm just 50. So
I think he enjoys singing with his two daughters. That's why.
I celebrate so many things. I celebrate learning with the students, so like spending time with family.
Uh-huh.
I don't miss any opportunity of celebration. So thank you. And Anjan Kumar Chaudhary, can I give my view? Anjan, go ahead.
No, personally, I if I just say, just add on to what Mary ma'am said right now, it's also about the comfort zone. Sometimes I think the comfort zone of adults, I think John sir put a really nice question here. I think, how do we, change that mindset? Personally, I can talk about myself as a teacher who is also doing the IB for many years.
Yes.
I know it's the comfort zone of, taking up the MAI program. Now, I can understand because Mary comes from the statistical background. I can see her passion the way she did and you did today, Jalaj. For us, sometimes, we also need to unlearn and, understand these techniques well. So often a very comfort zone is let's not do MAI. And, it trickles down. I don't know, maybe this is my opinion. And I personally want to change it, and I'm seeing my change in myself. Over these last 6 weeks, this entire TI workshop every Saturday has ensured, my own, love for the gadget and how it is such a powerful tool today. So, and especially with school opening now for many of us, many of these sessions will be very difficult to attend. So because I was in the break right now. So I feel that it is a mindset, which also as masters, sometimes we need to change. Now, I went through that, in the last 2 months. So I feel that it could be a reason why people are not taking up MAI, which I think is a far more better program sometimes than MAA today.
Anjan, just to add to that, when the new courses were announced and the first ever workshop, the IB workshop happened, it was my choice to go and attend the MAI. There was a category 3 workshop that is happening, I think at Oberoi International School. I chose to go for the MAI because I wanted to teach MAI. But unfortunately, I use the word popular opinion. The popular opinion in my school required that I should teach MAA. So imagine what had happened to me. I wanted to teach MAI. I go for the category 3 workshop for MAI. I come to school and they have asked me to teach MA, which means that I had to go for another workshop later, another 6 months. But there is a certain mindset, and you rightly use the word mindset. And I don't know whether it's just among students, which is why, yes, it was a fantastic workshop. We taught content, but also I think we as teachers who are influencers, there's a lot we can say. There's a lot how we present ourselves, how we present our subject. There is also a belief now that a student gets excited about a subject as much as this teacher is excited about that subject. So there has been maybe a mindset, even whether it's about from parents or also from teachers, because parents are also teachers in some way. A child's first education takes place from home. So it becomes very important for us as teachers to present the right attitude, the right excitement.
Yeah.
And so yeah, whoever we are, whichever background we've had, if we come up with that kind of respect. I think once when Jalaj and I were talking about that, I think we use the word respect, the respect that that subject actually deserves. Remember, restoring, restoring the,
it also depends on the university requirement, what the university required. Sometimes the university need MA. So suppose you want to go for the engineering and all, so you need their, so
no, that is correct.
Analysis and approaches you need there. And many universities, they give the requirement because students, they already choose where they want to go. They don't wait for the result. They first itself, I want to go to Singapore, or I want to go to the America. So it depends on that also.
No, that
university requirement.
That is a different issue. See, I will say that is okay, because first of all, a child is deciding to go to a particular college because of the interest in that particular course, and that course requirement perhaps is AA and to AI. That's fine. But to choose AI, not keeping the college requirement, keeping it for some other reasons, as to sometimes, I don't want to label, but I've heard it's happened in my presence. It's happened in my presence when teachers have, whenever during the orientation of IB, when there are parent-teacher meetings, teachers have very openly said that this course will not have much value. You know what I mean? So the way in the first sense when we've presented, what you said is a very correct point. If a child has to choose a particular course that is required in the university, that's a different story. But how we present to teachers with each other, and also I think, I don't know, I'm here, I think I'm just talking to myself here. When I hear a certain teacher talk like that, what should I do?
I think it is a debatable question. It will take a very long discussion.
Yeah, maybe not today.
It will be a really long discussion.
Yeah.
I see Pa Richard Castro. Do you want to say anything how your school accept MAI?
We just what we do, we just present the two courses, and then together with our career counselor, we try to present them with their options. And as far as the HL, AA, and AI, we do inform them that a lot of schools, they really don't mind whether you will be taking an AA or an AI on an HL level. But usually we also advise them, if at this point in time you already have an idea what career path you would want to take, and which universities that you plan to get in. We always advise them to take a look at the program, take a look at their requirements, and then we'll go from there. Because if the course that you want to get into says you need at least an AA, then we recommend that you go to AA, not the AI. That's how we do it.
Yeah, right. Yeah, I mean,
Once the students have got a question. Yes, Mary.
Yeah,
I've
I
got
think
it,
it depends on how teachers are doing the courses itself, right? How teacher making it like more attractive the courses is. Like, you know, last year our students, MAI students, did really good job, and they got accepted good schools in UK, and that was quite encouraging for many of juniors. See that, oh yeah, MAI doesn't really have disadvantage going to university. In fact, they have advantage because they have higher math grade. All right, I think this conversation can go on and on and on. We have like over time already 12 minutes.
Hi, Mary.
Yeah.
I've got a question to ask. Let's say once the students choose that they're going to pursue MAI, application interpretation. Now, which way shall I take them? SL or HL? AI SL or AI HL?
Oh,
because they don't have.
Okay.
I know this depends on their ability, but once I get the batch, in which direction I should take the course? HL level?
That depends on what other subjects the student take. Like other subject, how much demanding the subjects are, right? And how much a student is willing to invest time for AIHL. Because AIHL and SL, the gap is really, really big. The content is extremely expensive in AIHL. Dalaj, what do you think? You have taught AIHL, so you might have a better idea about this.
See, I approach it totally differently. Like, first thing is, I ask my students to make a selection on the basis of their university requirement, and I value all courses very, very highly. Even if it is MAIHL or MAISL, I value it highly, very, very. So that if a student is doing MAISL, they should feel proud of what they are doing.
Yeah.
Whether they are doing
what about MAI, SL, and HL? How can you guide students?
How can I guide, as in?
SL or HL. If student choose application. And how would you guide, right? SL or HL?
See, again, it depends on their like subject.
Yeah, I would definitely ask the student to look at the all 6 subjects, because whether it is manageable, AIHL require a lot of commitment. So I would say, can you manage that with other subjects? Like
sadly, some of the universities, they like to see HL is MAI. They don't really appreciate MAISL. Some universities, which is very sad. So again, it depends on the university requirement. There's so many factors.
Yeah, plus, a lot of factors, right? So yeah.
Plus.
And also students' work habit, right? And
yeah, we can't generalize it. It is quite objective thing.
Yeah.
I mean, quite subjective thing, I would say.
Yeah, it's very subjective, right? And that requires a lot of like other people too, university counselors and also IBDP coordinator, right?
Thank you, everyone. It was great.
Yeah, thank you, Marie. Thank you, all the participants.
Can I request?
Mubin sir, if you have any last question, you can ask.
Can I request you to take a session on Voronoi diagram?
Oh,
yeah, how?
Okay.
TI Inspire and Voronoi diagram, if it is there.
Definitely, Mubin sir. Definitely, we can arrange for that. Thank you for the suggestion. We'll definitely come back to you on that. Okay, thank you, everyone.
Thank you so much.
Thanks. Bye-bye.
Thank you.
Bye.
Bye.
Thank you. Bye-bye.
Thank you, Hassan. Thank you, Jalaj.
Thank you, Mary. It was a wonderful session. Thank you so much. Yeah. Jalaj, as usual.
Thank you. Bye.
Thanks. Thank you.
Thank you, Miss Elma.
Are we staying back for any last discussion?
Yes, Jalaj, we can stay back.
Yeah.
Sure. Marie, please stay back.
Yeah, sure.
Tea and cookies.
Can you deliver cookies here?
Full tea and cookies.
Let me go get some water.
Chiyoko.
I think she must have forgot to sign off. It's okay. I know Elma. Oh yeah, she left. Right. There are two more. Right, two. Okay.
I think we're gone.
Okay.
Jalaj, what is is it getting dark there, or is it the light in your room going off? What is
It's dark.